Welcome back! In our last explainer, we talked about the what, this incredible idea of our homes becoming one giant virtual power plant. It sounded like something straight out of science fiction, right? Well, today we're moving from the what to the how. We're rolling up our sleeves and opening up the actual blueprint to see how this gets built in the real world.
So here's how we're going to break it down. To build something this revolutionary, you need a solid foundation. We're going to look at the four crucial pillars: the tech that makes it possible, the economics that make it profitable, the people who make it powerful, and the security that makes it safe. Let's dive in.
First up, the technical foundation. You can't build a skyscraper if the electricians are using metric and the plumbers are using imperial. It would be chaos. Well, it's the exact same thing with a VPP. You've got your smart thermostat, your neighbor's EV charger, the solar panels down the street. They all have to be on the same page, speaking the same digital language.
Now, I know what you're thinking, a slide full of technical standards. But don't worry, you don't need to be an engineer. Just think of these as the rules of the road for the smart grid. They're the grammar and the vocabulary that allow all these different devices to communicate, from basic safety rules to the super-fast messages VPPs need to send in real time. Now,
And this all boils down to one magic word: interoperability. It's a fancy term for a really simple idea. It means your Google thermostat can talk to a Tesla Powerwall, and they can both understand a signal from the local utility company seamlessly. Without this digital handshake, the whole VPP idea just doesn't work. It's that crucial.
So you can see how each of these standards plays a specific role, kind of like a team of specialists. You've got IEEE 2030.5 acting as the secure bridge for all the communication. Then you have OpenADR as the super fast messenger, zipping urgent commands back and forth. And SunSpec Modbus, that's the universal translator, making sure everyone understands what the data actually means. Together, they create one smart, coordinated system.
Okay,
So you can see how
so the tech works, the devices can all talk to each other. But what about the money? For this entire revolution to really take off, it has to make financial sense. It has to be profitable. So let's talk about the economic engine. And this is the million-dollar question, isn't it? How can my little smart thermostat or the EV charger in my garage actually generate real money? I mean, on its own, it's just a drop in the bucket. But what happens when you connect it with thousands or even hundreds of thousands of others? Well, that's when things get really interesting.
The secret sauce here is a strategy called revenue stacking. Here's how it works. First, an operator groups all those small devices into one big pool. Then, that pool acts like a financial powerhouse, participating in multiple different energy markets all at once. Smart software is constantly scanning for the highest-paying gig, stacking up all these different income streams on top of each other.
The difference is just massive. It's like a freelancer who can only do one job a month versus one who's juggling 4 or 5 at the same time. A VPP isn't just selling back a little bit of power. No, it can also get paid to help keep the grid's frequency stable or to be on call as an emergency backup. Each of those services is another layer of cash, and they stack up to create some serious value.
For a perfect, real-world example of this, look no further than data centers. These places have enormous backup power systems, huge batteries just sitting there collecting dust waiting for a blackout. A VPP allows them to turn that idle, dead asset into an active, revenue-generating machine. It's a brand new income stream without having to buy any new equipment.
All right, so the tech works and the business model makes sense. But there's one more critical component, and honestly, it's the most important one of all. People. Us. A virtual power plant isn't a building somewhere. It's literally powered by the millions of us who choose to join in.
So how do you get millions of people to sign up? Well, it's not really about the fancy tech. It's about trust. It's about human psychology. People need to see a really clear benefit for themselves, and they need to know without a doubt that their data, their privacy, and their homes are being protected.
And this isn't just a theory. Take a look at the APS Cool Rewards program in Arizona. They've figured out a super simple way to get people's attention. $50. A $50 credit on your bill right up front just for signing up. It's direct, it's simple, and guess what? It totally works. Thousands of households have enrolled because the value is crystal clear from day one. So really, a program that people actually want to join boils down to this: clear financial perks, rock-solid security, easy-to-use tools that keep you in control, and, importantly, making sure that these benefits are available to everyone in the community.
Okay, on to our final and perhaps most critical pillar: building a digital fortress around this entire system. Because as we build a smarter grid, we absolutely have to build a more secure one. You see, here's the paradox.
The very thing that makes a VPP so powerful, connecting all these thousands of devices, is also what makes it vulnerable. Every smart thermostat, every EV charger, every solar inverter, it's another potential door that a cyber attacker could try to open.
So how do we solve that? The answer is a principle called privacy by design. It means you don't just build a system and then try to patch security holes later on. That doesn't work. Instead, security has to be part of the blueprint from the very beginning. It's baked in, not bolted on.
But let's be real. How do you actually monitor a network this huge and complex? We're talking about thousands, maybe millions, of devices constantly communicating. Spotting a single threat in all that noise is like finding a needle in a haystack during a hurricane. But let's be real. The way you do it is by knowing what normal looks like. You use machine learning to create a detailed profile of the VPP's everyday behavior, the normal ebbs and flows of energy, the typical communication patterns. Once the system knows what's normal, it can instantly spot anything that deviates from that baseline and flag it as a potential threat long before it can do any real damage.
So, let's zoom back out and put all of these pieces together. We've walked through the 4 essential pillars that form the complete blueprint for the grid of the future.
You've got the technical standards, so all the devices can speak the same language. You've got the economic engine, so it's a profitable venture. You have the human element, which is built on trust and clear benefits. And finally, you have the digital fortress to keep the whole thing safe. And the key is you need all 4. Take one away, and the entire structure gets wobbly. Brings us to our final thought. The plan is here. The technology isn't science fiction anymore, it's real. The economic models are proven. We literally have the blueprint in our hands. So the question is no longer, can we do this? The real question is, what are we waiting for?